artificial intelligence in ophthalmology, and we have speakers in both engineering side and medical side. And we have Dr. Kim, Dr. Rajlakshmi, Dr. S. Natarajan would be there, and we have two people from engineering stream. We have Dr. Akinaro Mitani from Google US, and we have Dr. Surbhi Gupta from Microsoft. So I think we'll have a more complete perspective of how artificial intelligence is today used in ophthalmology. So we'll not waste the time, and I'll request Dr. Akinori Mitani, who would be talking to us on basics of deep learning in retinal image analysis. Dr. Mitani studied medicine in University of Tokyo in Japan and obtained his PhD in neurosciences at University of California, San Diego. At present, he is working as a software engineer in Google in the team applying the deep learning to the healthcare. Please.
Hello, everyone. Thank you for the kind introduction. My name is Akinori Mitani. I studied medicine in Tokyo, and then now I'm working for Google applying machine learning to healthcare. So before talking about deep learning, there are other words, similar words people use almost interchangeably, like artificial intelligence, machine learning, and deep learning. So let me explain how we see those words. So artificial intelligence is a system which can do smart things. Like if we can show a picture of either a dog or a cat, and the system can tell whether that's the dog or cat pictures, that's an artificial intelligence. And there are many ways to achieve it. And one way to do it is to build a system which can learn from examples. And we call those machine learning. So in this system, we show thousands of cat images and thousands of dog images. And after that, the system can tell cat and dog apart. And one of the implementation of machine learning is deep learning, which has shown to be very useful and powerful in the last 5 to 6 years, and has been the best performing models in many fields. So what is deep learning? It's an artificial neural network. So it consists of many trainable mathematical units in many layers, and that's why it's called deep. And so if we input a dog image to the system, first it's translated into the activity of those units in the first layer, and then the activity of the units in the first layer is translated to the activity of the second layer, third layer, and finally, in the final layer, those two units, the activity of two units tell whether the original image was a cat or a dog. And the point is the connectivity between those units are trainable. And while it processes thousands of examples during the training phase, they learn how to connect them and learn how to do the task. So this system turned out to be very accurate and very powerful. And the thing is, this learns from the examples. The same structure can be used in many different tasks. We just have to prepare the examples with correct labelings, and the network structure handles can learn from those examples. So the idea of the machine learning and deep learning and neural network itself has been around for 50, 60 years. And the reason why it became so popular these days is the development of the hardware. And now we can train a lot more complex models, and we can train with like a lot more examples. At the beginning of the artificial intelligence, more handcrafted features. So for example, in ophthalmology, detecting blood vessels and detect like how thick they are, like how what's the curvature of them, and setting some threshold to detect some diseases. Those systems has been around, but the performance has never been on par with human graders. But with the machine learning, with the deep learning system, the performance has getting close to or even better than human graders sometimes. So why we want to apply machine learning to medicine? There is a few characteristics of the field where we want to apply deep learning. So the first, the field has to have a lot of data. It's important for both training. We need the data to begin with, and also the amount of data means there are a lot of room to actually apply the deep learning. And it has been shown that 150 exabytes of data is in the US right now, and it's going to increase even further. And another thing is the expertise is very limited, so we just don't have enough professionals to go through this data. This shows the shortage of radiologists in many areas of the world, and India is not the exception, and ophthalmology also suffers from the same problem. This picture shows a line formed in front of one of our partner hospitals, and people are waiting in line to get their eyes exams. And it's expected that it's reported around 100,000 eye care professionals are insured in India. So we wanted to use deep learning, machine learning to close this gap. The reason why we focused on diabetic retinopathy first is that there are 400 million people with diabetes in the world, and it's expected to increase even further. That means these patients are at risk of developing the DR and eventually become blind. So we wanted to stop that. The one good thing about diabetic retinopathy is that the blindness can be prevented. So this is the fundus image from a healthy individual, and as the disease progresses, there become hemorrhages, and their retina develop those symptoms. And ophthalmologists has been classifying the disease progression in multiple classes, and we want to either refer or do some treatment like anti-VEGF injection or laser coagulation to the patients with developed diseases at the right time. But it needs regular screening, but there are 400 million patients, and how can we screen those patients regularly? So we wanted to develop a deep learning algorithm to do that. So we first obtained 130,000 images from our partners, and we hired 54 ophthalmologists to grade them, and we get in total 800 diagnoses. And one of the issue is that we ask different doctors. The doctors may give different answers, and there are many ways to come up with a single label. So taking a majority vote between them or going through some education process so they talk with each other and come up with a label. But it's very important that we get a single consistent labeling, both for training and evaluation. And with using those labels, we train a deep convolutional neural network, and the structure of this network is the same as the one we use to classify consumer images like cats, dogs, bikes, cars, and those things, called inception model. And this model outputs the class of DR and also the image code D, whether they are gradable or not. And using those systems, our system gets close to or on par with the specialists after several tuning. So when we talk about the performance of the model, the one thing that's really important is we have to really care about the difference between training error and the validation error. So because the system learns from the examples, they tend to perform better with the examples they are trained on. So it's important to have a complete separate data set to evaluate the performance of the model. And even better, if we can fix the model and test with the data collected later, that's a prospective research study, and that's even better. So we are now working with Arvind and Sankara to do the prospective research. And also, we are working with several regulatory bodies to make sure we meet their standard so that we know that our model is going to do well in the actual setup. And also, we are partnering with hardware companies and like Nikon, and Very is another alphabet company like Google, to make the system integrated and more streamlined process. And to focus a little bit more about the research partners, we are working with Arvind, Sankara, Natriyata, Narayana, National Yara to do and actually deploying those systems to help the patients and also do some further research. One additional thing we found is that those deep learning systems can do something people haven't really thought about because they do see those fundus images a little bit differently from humans. For example, here we showed that from the fundus images, the model can predict the refractive error with great precision. And additionally, we can look at how those models are doing it, and it's looking at the center of the image. And also, we looked at what else clinically relevant information we can get. And we looked at the cardiovascular risk factors and age, gender, or HbA1c. We can predict those numbers. And this can be additional information we can get or we can use in the screening setup. So as a summary, artificial intelligence has the potential to improve healthcare through scalable screening. So it increases the patient's accessibility to screening, and each location with a streamlined process can screen more patients. And patients know their grade immediately, and also the gradability will be available. So that means the technicians can retake the images if necessary instead of going back and forth. And patients can be referred to ophthalmologists without coming back, so there is no dropout during the reference process. And additionally, like the refractive error or cardiovascular risk, those additional information may be provided to them. So through the partnership with the hospitals and everyone, we think we can provide those information, provide those benefits to the patients. Thank you.
Thank you, Dr. Akinori. Any questions from the audience? Thank you for presenting such a beautifully the basic work that has been done. I was wondering if we have more and more images coming in. Suppose there are going to be images coming from different cameras, lower-end cameras, high-end cameras. How would the algorithm react to those?
So first of all, just having more images, the performance usually increase. And also having different types of images, as you mentioned, improves the generalizability of the algorithm. So if you only train with images from one camera, the algorithm perform better with that camera, but may not perform that well with others. But collecting images from many different cameras or different setups, the algorithm will better generalize to more setups.
To add, in the JAMA paper, it was actually because on a limited number of cameras, but it showed that more than 60,000, if you increase, the performance was not changing much.
Yeah.
Because that's what they said, that we could find out after 60,000 increasing the sample, it was not changing.
So, I mean, definitely there can be some limit, and the return of increasing the number of training examples will become smaller and smaller. So there is a trade-off between them. But then we still think there is also room for exploring the structure of the network. It's really hard to show that's a true limit, or there is more room to explore. So we are expecting to further continue research on that field too.
Thank you, Dr. Akinori. Can I ask next Dr. Rajiv Raman to speak on the comparison of different AI models in DR screening? I'm sure he needs no introduction. He's a senior consultant at Shankar Nethralaya, working a lot on diabetic retinopathy and, of course, on AI.
Thank you, sir. Slides. So, next couple of minutes, I'll be sharing some of the different AI screening models which have been developed for diabetic retinopathy and try to compare these. So, AI for diabetic retinopathy screening is very much there. It's not just a research which couple of years back, it was just thought that it's a research tool. And I was actually looking at that diabetic retinopathy came now. There are many AI devices which have got approval by FDA. And if you look at the list, much more in cardiology, in neurology, and I was initially thinking that diabetic retinopathy FDA approval was the first one, but to my surprise, before that, there were a lot of algorithms which got approved. So there was a trend, and now in ophthalmology, IDX in April 2018 was the first AI algorithm to get approval for screening diabetic retinopathy. This is just a small video completing the Google ARDA video, how the pathway, how the diagnosis happens. So you put an image, it starts analyzing and gives the gradability, the various grades of diabetic retinopathy, grades of diabetic macular edema, and a report is generated. After the 2017 16 paper, there has been a surge of publications related to deep learning in diabetic retinopathy, and there are recently we have published a review article in Eye which covers nearly 32 algorithms, all based on deep learning, and the performance in each one of them. In GIST, many of them showed good performance, meaning more than 95% accuracy. Now, many of these, when you see the analysis, it is all the AUC. I won't go in details of that, but basically it looks into this confusion matrix and tries to find out what is the accuracy rate. Okay, so you have a label. Label is a presence absence of retinopathy, or the grade of retinopathy, whether this grade is present or absent, and you have the true label. Now this is important thing, that how this label has been collected, because if this label is wrong, the predicted the comparison, or you will say a falsely bad performance or a very good performance. It all depends on this label. And so this was the April 2018 FDA permitted the first AI based device, the IDX, and to get this approval they had put a primary endpoint was sensitivity more than 85% and specificity more than 82.5%. This was the cutoff which FDA had kept, and we tried looking at all these 32 algorithms, how many of them fulfill this criteria. So the high sensitivity, you can see all those red dots, they were more than what FDA had recommended. So, and those black dots again are one which fulfill the requirement of FDA. So that means many of the devices which are currently available or people are working on, they all fulfill requirement of FDA, and soon we will see many of these devices. Just we'll take example of the Google AI algorithm which I have been working with, and for moderate plus diabetic retinopathy, the sensitivity specificity is 90 and 98%. For severe plus diabetic retinopathy, these are the sensitivity specificity, and for diabetic macular edema, again more than 90% sensitivity and specificity. So this shows a relatively good performance, a very good performance as compared to many a times the graders. So when we try comparing these algorithms, what we need to look is how the ground truth had been obtained, because the garbage in and garbage out is a term which is used in engineering science, but that's what is very much true with AI. How the diagnosis was made. So there are a variety of ways the ground truth could be obtained. In the JAMA paper, we had a majority grading. So we had 54 ophthalmologists doing the grading, and the majority grade was taken as the grade. The next one is three graders and expert. Again, many of the epidemiology study, we all are, as ophthalmologists, we know the Wisconsin and ETDRS, where the grading was. There were three ophthalmologists who did the grading. If there was a disagreement, there was a fourth expert. His grade was taken as a final grade. Or we do a multiple grading, still the three gradings are same. And what later on another paper in ophthalmology from the Google group, we tried looking at the educated grade, means the three people sit together. If there is a disagreement, they talk and come for agreement. So there are a variety of ways the ground truth is obtained. But unless, again, the lowest evidence would be one person just doing a grading. because that's, we know there is a lot of, doctor showed the variations which are there among the ophthalmologists. Okay. Performance may change. This was again the paper, the ophthalmology, the Google paper, where they compared with their JAMA paper, where they had done a majority grading. And you can see the performance actually changed. The AUC was 0.93, it became 0.98. So the way the grading or the ground truth is obtained plays a very crucial role in these performance of these algorithms. Is there an influence of camera? This is one of the work which has just come in public domain, which is a work from Thailand, which we have been working there. And there we had opportunity to work on multiple cameras. This is across all the districts, all the places, all the provinces of Thailand. And in this study, we didn't find any difference in algorithm. However, the percentage of non-gradable images vary depending on handheld camera versus a tabletop model. But performance of AI on the gradable images were same. Again, there are some differences in algorithm in terms of ease of integration, whether you want to use it in a rural setting or urban setting. Majority of algorithms today are online. You put a image and online the diagnosis comes. One of them, the Remedio, which they have developed, is an offline model where you need not need a net connectivity, which may be good in some of the regions, some rural areas and the areas where internet connectivity is not good. And we will see soon many of these type of models coming up. So just to conclude, last 3 years, it's been mainly the evidences on development and testing of AI algorithms for diabetic retinopathy. And next couple of years, we'll be seeing more of real-time implementation and seeing how we can adopt these, so that because every place there are a lot of variables in diabetic retinopathy screening, and how the AI algorithm fits into the existing system would be something which we'll be seeing more evidence in next 2 years. Thank you very much. I'd like to invite all of you for the 4th Retina Summit, which is on 12th and 13th of July. And this time it's all about pediatric retina. Thank you. Any questions? I'll be happy to take. Yeah. Yeah, that's what, see the ground truth, majority, the opinion changed, and that paper tells that which were the ones which were misdiagnosed by the majority grade, which were picked by very well here. Now again, what is ground truth is a big question, which is the correct one, but the way you collect the data, this seems to be a more logistic way than 3 retina specialists giving a diagnosis, and if there is a disagreement, rather than having a 4th expert, they come to a consensus. Okay, I think that's.
If some mistake or something occurs, who takes the legal responsibility?
It's a very good question, but the question is, like, mistake in what sense you are looking? That means the miss rate, like PDR you miss, correct? Yeah. Now, I looked. This was a question which I was wondering that what should be the miss rate for a PDR. Now the question is, if you look at many other specialities like troponin, there is a 10% miss rate for a acute coronary event. It can miss bedside troponin. MRI for a stroke, it is 15% miss rate for a stroke. Now these are the investigative tools where we know, so any of these models, if they are showing more than 95% and miss rate, if suppose, or false negatives are less than 10%, because there is no guideline, that seems to be a reasonable good. Now coming again, whether who is legally I think we need to go a little long way, because I don't think much regulations are there. There are countries who have done, like Korea have come out with their own guidelines. There are regulations. I'm sure those will come to India too.
Thank you, Dr. Rajiv.
first, Dr. Kim. He will be talking on real-life experiences with artificial intelligence in diabetic retinopathy screening.
So we've been working on this for some time, as Raji pointed out, for the last 3-4 years, and Kinori had shown what is the machine learning and deep learning. So today there are multiple places, as Raji pointed out, where AI has been approved by FDA. But the current, the algorithm that we have been working on is yet to be approved. They say that the C certification is almost there, but so to use it independently is not possible at this point of time. But how AI makes a big difference in ours is because of the images. Most of our diagnosis is based on images, and so it becomes more applicable in the ophthalmologist, just like the radiologists or the dermatologists using this. And we have a clear-cut guidelines, the grading system and the grades that have been well established. So we have been using this as a grading, the opportunistic screening. We put cameras in the physician's office for the last 15, almost 17 years, trying to take their, whenever a patient walks in, because that is where you get the target population and not the patients who are walking into your clinic for ophthalmology. So we call it as opportunistic screening because every diabetic patient would get a fundus photo taken and their image is read through telescreening by an ophthalmologist or a trained grader, and a report is sent back. So the whole idea is that the whole grading is so inconsistent, as Akinori pointed out. When 2 or 3 different people are grading the same, a PDR could be read as mild or moderate, as you can see in this, where even a proliferative diabetic retinopathy was considered as a mild NPDR. So this, our study done earlier had shown a very good high sensitivity of 97% and 96% sensitivity and specificity in our earlier studies, and I think most of this have been read. So today what we are trying to do is we are trying to introduce the ARDA. So every patient the physician takes or the diabetologist take is subjected to ARDA, is the Google's algorithm. At the same time, the image is also read by an ophthalmologist or the trained grader in the base hospital. And once he finishes grading, the ARDA's report comes into his reading. So if there is any difference, then it is sent for adjudication to a senior level or a senior retina specialist to see which is the ground truth. And that is generated as a report and sent back to the to the diabetology clinic. So this, we call it as assisted grading and not an independent grading by ARDA at this point of time, for a simple reason: it's not certified by anybody at this point of time. So we are trying to do, as Kinori and Rajiv also pointed out, performing these real-time scenarios. How does it work when we are using on the real scenarios? And we have seen that the sensitivity of 88.9% and the specificity of 92% was there for moderate plus DR grading. So those patients who had moderate or more than moderate diabetic retinopathy, the sensitivity was quite high. Both in Arvind and in Shankarnetralaya, it was 92% and the specificity of 95%. It did work well even for when we looked at the diabetic macular edema, a sensitivity of 97.4% and specificity of 90% in the Arvind's group of images, and in Shankarnetralaya it was about 93 and 92.5% sensitivity. So it did show that it was doing very well in comparison to the ground truth. And so the whole idea is that over time we will remove the entire grading of human grading being there, and the images that come from the physician's office or diabetologist's office will locally be uploaded to the ARDA, and they get a report within a few seconds, and there's no time delay for the patient, and with much more sensitivity and consistent way of grading. So that's what we are looking at. We're also deploying, we have been using these cameras in our what we call as primary care centers or vision centers, where only a technician is present doing the complete examination of the patient, where the diabetic patient's fundus photos are taken and sent for grading. We are currently using the ARDA as an assisted grade, but soon we hope, like with all the algorithms available, I mean, there's been, people are working on glaucoma, people are working on AMD, and all the other common retinal pathologies that will be available, and if they could be put in place, then we could have a system wherein the primary technician or a primary care provider could screen the patients and triage the patients. Only those who have any serious form of retinal pathology or any disease like glaucoma could be referred to the ophthalmologist, so that it gives more, the ophthalmologist did not screen through these normal patients. So we have had a few challenges in technical using, the technicians using these cameras. Still the acceptance from the physician is questionable. We have to wait for them to see how it matches, and we have to convince them on the grading system, how it works better than the human grading, and sometimes getting consent from the patient, because in all these we have to get consent from the patients that we are doing this as an assisted grading, but sometimes it becomes a challenge. The other thing is the types of cameras used. Still we need to have a very good high resolution cameras, and currently they are available. The algorithms need to be trained on all cameras, as I was mentioning earlier, and of course the technician needs adequate skill to get good quality images, but today there are few cameras which are automated. Of course they are still expensive. There is no role for the technician other than just entering the data that anybody can do, and the camera itself automatically focuses on the different areas for the patient to see, and then we get a very good resolution, I mean high resolution images even with 2.5 millimeter pupil. So what's next? To determine whether the use of these algorithms could lead to improved care and outcome compared with the current ophthalmic assessment is something that we have to study with time, and this is what we are currently looking at, how these images, if we did independently, how would it function versus a physician or a trained grader grading these images. As somebody said, Andrew said that AI is the new electricity. It's going to change a lot of things, as we all hear about AI in every field, not only in healthcare, but automotive industry or any industry, even in judiciary using AI. So it's not something going to be, we cannot stop it, but it'll be there. How we adapt it is more important, and how we use it is very, very important in this. So I thank you for your kind attention.
Any questions?
Yes, sir. Yeah, see, at this point of time, this is only a screening tool. We are not doing any treatment at this point. But there are a lot of work is going on OCT, interpretation by AI. It's happening at this point of time. So it will definitely make a huge. Oh yes, yes, definitely that attempt is happening. People are independently working on different levels of OCT interpretations. So I think it's only a matter of time when all this will be there.
Natarajan is not there, I'll ask because he may join later. I request Dr. Rajlakshmi to talk on challenges and limitations of AI in diabetic retinopathy screening.
Good afternoon to you all. I would be talking about the challenges and limitations of using artificial intelligence for diabetic retinopathy screening. Though I would be showing images of the artificial intelligence software that we have been using or we have tried as a trial, there are no conflicts of interest or financial disclosures with multiple AIs being available in the market right now. We are all aware that India is home to over 72 million people with diabetes. How many of them are going to come to meet us ophthalmologists unless they are going to have any ocular complaints? The primary point of contact for these people are definitely going to be physicians. Are the physicians going to be interested in investing in high-end cameras, which are expensive? Even if they take retinal images, who's going to grade the images for them? Again, for that, they have to be dependent on retina specialists. And if the retina specialist is going to spend their time only on screening and looking at these retinal images, when will they have time to manage their patients with other diabetic eye disorders? So given the alarming increase in the number of people with diabetes and the shortage of trained retina specialists, a solution to reduce the burden of healthcare systems is an urgent need. And artificial intelligence is definitely the solution. I would like to start with an example. A 43-year-old male with type 2 diabetes of just 3 years duration went to one of our diabetology clinics at Tanjavur for a routine diabetes checkup. His vision was normal. He had no specific eye complaints. He underwent a retinal photography with a low-cost camera, which was just taken by a trained eye technician. The images were sent to me through our hospital tele-ophthalmology network. And simultaneously, after we published our use of the AI, we wanted to just see how it works real time. So the images were also uploaded by our technician for AI diagnosis. So this was the camera which was used, and you have the pictures taken on the camera. There are no extra marks or prizes for the diagnosis. All of you would definitely be able to make out what the diagnosis is. And here you have the AI report. And I don't know how clear it is from here. It says signs of proliferative diabetic retinopathy with surrogate markers of clinically significant macular edema present in the patient's fundus photographs. So here, our diabetologists had the AI-assisted diabetic retinopathy diagnosis of PDR and DME available with him instantly, even before I could send him the diagnosis from my side, because I had to see patients in between even before I could do the grading of these images. And this patient, who was totally asymptomatic, thanks to teleophthalmology and AI, though we don't give these reports to the patient, this is the kind of AI reports. It's so accurate, and this patient could come for FFA OCT and pararetinal photocoagulation thanks to teleophthalmology. So let me talk about the advantages of AI before I go into the challenges and limitations. It is definitely very fast, and it is quite accurate. As Dr. Rajiv showed and Dr. Kim showed, most of the AI show an accuracy and sensitivity and specificity of 95% and above, and for detecting DR, referable DRs, sight-threatening DRs. It is a highly scalable process with a very quick response time. See, at the end of the day, after seeing my OPD, if I have to see about 100 retinal images, I may accidentally, as a human, miss a grade, whereas the AI algorithm is never going to tire out. Patients, even in rural areas like this patient, who was from a village near Tanjavur, he could get access to AI screening. So this early detection, actually, as we saw in that example, could enable this patient to preserve his vision. And as you can make out the real kind of interest that AI has generated among all of us, basically you can see the number of publications from 2016 to 2018 on diabetic retinopathy has really crossed so much when compared to what it was about 10 years ago. And this, you can see the publication by the Google team, by us, the review paper that I and Rajiv, we wrote together, and the publication from the Singapore team, etc. But what are the challenges? The first thing is, an artificial intelligence system is data hungry. It is data hungry because the deep learning requires thousands of retinal images for learning to provide an accurate diagnosis. So it needs proper curated data sets to help train the deep learning technology. So we are aware, as Dr. Kim mentioned, there are multiple fundus cameras of different types, different brands, and different image qualities. Is it possible for every AI system available in the market to be trained with retinal images of all these fundus cameras? And again, the training and tuning is subject to the field of view, whether it is an ultra-wide image, whether it's a 30-degree image, it's a 45-degree image, the amount of magnification, the image quality, are there any artifacts, etc. So it is very important for the curated data sets that are provided to the AI systems to be robust, diversified with ethnicity, the different cameras, and that becomes a must for quality AI diagnosis. And of course, now that people like Aravind, Shankar Nethralaya, our hospitals, we have tried using AI as more like studies. Now, the current challenge is in clinical validation and real-time deployment in our clinical practices. But what we really don't know is regarding, we know that the AI that we are using is CE marked, it's waiting US FDA approval. IDX as of now is the only AI which has been approved for DR diagnosis, etc. So what do we know about AI approval for regulatory approval? Should the drug controller be approving it? Should the health ministry be approving it? Can it be just be used as an interface? And suppose there's a liability, who bears the liability? Would it be the errors or any malfunctions of the AI system? Is the ophthalmologist liable or is the hospital liable? Those are unanswered questions. And what about the ethical and privacy questions? We are sharing the retinal images of our patients on an AI platform, on a cloud. So where are there issues to the privacy? So it's very important that before the images are uploaded to any AI platform, that they are de-identified and depersonalized, whether it comes to ophthalmology images or radiology images, because these are like patient identifiers. Talking about other limitations, we know that when we are taking images, particularly in camps and screening, etc., many times due to poor mydriasis, cataract in our patients, image quality is very poor. And once the image quality is poor, the AI algorithms, usually they cannot overcome these physical limitations. And they just say it's ungradable, and hence it becomes an indication for referral. The machine may miss things that the human grader may notice unless it is trained to identify that particular problem. Say, suppose, like in this report, it shows as green that there is no DR, and it may give a patient a sense of false security. Otherwise, this patient, for instance, you can see that the cup-disc ratio looks a little asymmetrical in this picture. And if an ophthalmologist had seen, they might have advised a field test for this patient. But with the green, the patient may have a false sense of security that his eyes are fine. So if an AI is trained only to identify DR, it may not be identifying other pathological problems, say like glaucoma or ARMD, which could possibly happen in the future. And again, with one single field image, the chances of missing certain findings is possible, and probably at least 2 images per eye, 2 fields per eye, may be a better option to avoid missing any important retinal diagnosis. Again, are there any possibilities of overdiagnosis? If we see a mutilated nerve fiber, we as ophthalmologists can ignore it. But what if the AI is going to overinterpret it by any chance, unless it is properly trained with a curated data set? It could mistake it for a fibrous tissue. And this was a very interesting thing that we saw. What happened was we sent our retinal camera to an old age home for fundus imaging. After the camera came back, we were in fact very happy with our AI, where we saw that it was almost 100% accurate. We didn't have any errors. And suddenly we started uploading the images taken at the old age home into our AI. And suddenly we found that even the normal, no DRs, were getting reported as DRs. And what we noticed was, you can see that there's one black small dust there. And that small dust particle was present between the mobile camera and the attachment. And that small dust particle was making the AI misreport it as DR. So was it the fault of the AI, or was it the fault of the optometrist who took the pictures? This was an accidental observation. These things we have to bear in mind and keep a caution. And that is the one main fear that all of us have. Will AI replace ophthalmologists? We all know, at least at the moment, that AI only provides diagnostic support. It will be only an auxiliary part in DR screening. There is definitely a fear that the graders may lose the jobs, as these machines will definitely do the job much faster and more accurately. But it cannot replace ophthalmologists. Once the patients are screened, those patients who have referable DR will definitely need to meet the ophthalmologist. But it can ease the pressure on the healthcare systems. So to conclude, AI will empower physicians to detect DR in the absence of retina specialists with immediate results, as I showed you in my first slide. AI-based DR diagnosis has very high sensitivity for referable DRs. But curated retinal image data sets, diversified with ethnicity and different cameras, will become a must for proper deep learning. AI will be useful for mass retinal screening. AI is very appealing because it fits into the current trend of teleophthalmology, but image quality will have a major role to play in the accurate diagnosis by the AI systems. The AI solutions in the future should become extensible to detect other eye disorders like glaucoma and ARMD. AI is not an AlphaGo that will eventually replace the ophthalmologist. Real-time deployment of AI in clinical practice will happen, but it should happen with care and caution. We need to tackle the technological, ethical, privacy, and the legal obstacles which is associated with AI. Long back, Albert Einstein said, artificial intelligence is no match for natural stupidity. Should we really be concerned about artificial intelligence? I don't think so. Let's make AI a helpful assistant for retinopathy detection. Thank you.
Thank you. Any questions? Dr. Natarajan, you are presenting? Yeah, please, please.
Just as there are, there are ethical guidelines for journal publishing, etc. Same way, till now, is there any regulation or ethical guidelines for use of AI?
See, first thing is,
In the sense, let me clarify, in the sense, are there any laid down guidelines that it can be only applied in minimum of, say, 2 images per eye, or anything, any guidelines, or is anybody working on guidelines on that?
I don't think as of now there are any guidelines. I think the US FDA, the IDX which got approved, worked on 2 images per eye, and that is as of now the only US FDA approved. Majority of the CE marked devices, CE marked as one of the, at least for the softwares, but when the software is behind, if it is incorporated into does a software, it is not like a drug, it is only a software. How is it right to say that it has to go through an authority? Only thing is, when the more number of images, the more merrier the AI algorithm is going to be, because the less chances of missing anything. So I feel the more the number of images, the better it is for accurate diagnosis.
So till that time, what do you advise when we have like what I'm saying? At present, somebody was asking yesterday. So I said, if you are going to send away, at least we are counter checking with at least the chief guest was asking
right
me.
Now
Do you depend on AI? He asked me. So I told him we are depending. I said one company, same thing I answered him. But I said we are counter checking with ophthalmologists now, our reading center.
Correct, sir. You're right.
Okay.
We are using it as an assisted reading,
Right.
not for independent reading. But then again, saying that we don't know the legal implication, because even for tele-screening, we don't have a good guidelines in India, which is being drafted at this point of time. So after this, they'll probably work on AI.
Which department will do this screen line, the guideline?
It's happening between the DIT, that is Department of Information and Technology,
Okay.
and there is some happening with the Health Ministry also.
Okay.
So there is somebody, there's a group that is being formed and working on it at this time.
Okay. Good.
I'd request Dr. Natarajan, he would be talking to us on use of offline AI on smartphone-based fundus photography in screening of referable diabetic retinopathy.
I thank Rajiv and Kim for organizing this, and thank Lalit Verma for including this. And I think already Dr. Rajiv and Kim are working along with Dr. Rajalakshmi and on many things on DR screening, and one of them is the AI. And AI, usually you need internet, and then you send image goes to the cloud, and then with the machine learning, answer comes back. In this offline, the following presentation is based on outreach and in clinic diabetic retinopathy screening, work done by AIOC2019 Foundation for Twinkling Little Eyes. There is no financial interest, and with the ever increasing number of diabetes, which all of us know, and the solution is to have screening. So we have made a committee in the All India, and I'm happy we are rolling it out along with Dr. Rajalakshmi, Dr. Kim, Dr. Ajit Babu, Dr. Lalit Verma, Dr. Partha Bishwas, and Dr. Radhika Krishnan. And we have this screening through teleophthalmology for prevention of diabetic blindness, which Jyot Se Jyot Jala, and we are in the process of making a process flow so that anybody can take the document and follow it, which the task has been given to Dr. Rajiv Raman to coordinate and do it. We had a meeting on January 20th in Shankar Netralaya. Thanks for hosting that. And we have this is the process flow we have proposed, which again it is still not ratified by our own group. And then after that, probably we have to make sure whoever is working on will accept this process flow, the pre-camp awareness, assembly of diabetics, and Dr. Am is doing it from 2002, and I don't know the year, but Dr. Rajiv Raman and group are working on SN Dreams, that is a Sankarnath Diabetic Retinopathy project. And then where they are working on various and now we have Ornate India, led by Dr. Shobha Shivaprasad. Diagnosis by ophthalmologist was everybody is doing even now in the remote places. Then the image graders at reading center, and we have the online AI and offline, which we just had. So this is one of the where funders on phone by Remedio. Again, no financial interest. There are, at least right now, this is the only company available, where the idea was to use a phone which can be chargeable, and you can also portable, and then the infrared source for taking a non-mydriatic photograph, which is the portable, which also can be charged, and a low maintenance and internet connectivity. Whenever it comes, you can send the images and easy retrieval of data at a reading center. And that was the idea. And this is the photographs taken in funders on phone and size. And currently, most AI require a processor-intensive environment for their successful use and deployment, especially on the cloud. However, there are many parts of the world where access to a stable internet connection may not be assured. And the Meteos is a company registered in Singapore with one Indian and one Swiss guy have partnered and working, has directly integrated into the Remedio non-mydriatic funders on phone control app and seamlessly integrates into the image acquisition workflow. A representative subset of lesions are also highlighted by the AI on the image for patient education and physician review, and that's how the highlights happen. And then grading by the Meteos AI algorithm is designed to diagnose only referable diabetic retinopathy and no diabetic retinopathy. It does not grade the stages of diabetic retinopathy. The referable DR was defined by the presence of moderate to severe non-proliferative diabetic retinopathy, proliferative diabetic retinopathy, and/or diabetic macular edema or clinically significant macular edema. And this was a prospective cross-sectional diagnostic accuracy study done by Dr. Radhika et al. Known cases of diabetes visiting the municipal dispensary of Mumbai were included. Fundus images of both the eyes were taken and uploaded and saved on cloud storage space. An ophthalmologist seated in a distant location sees the images and grades the severity of retinopathy. The AI incorporated in the camera was also used to grade if the retinopathy was referable, and the ophthalmologist grading of the image was masked to the results of the AI. The sensitivity and specificity of AI in detecting referable diabetic retinopathy was then calculated. This is the first study validating performance of an offline AI algorithm, and the first study using the AI on images taken by a non-specialist in outside of clinic setting. And FDA superiority endpoints for the referable diabetic retinopathy. Sensitivity is about 85% and specificity 82.5%. And the sensitivity and specificity of AI in detecting referable DR was 100% and 88.4% respectively compared to ophthalmologist grading and no false negatives. The sensitivity and specificity of the offline AI in detecting any DR was 85.2% and 92% respectively compared to ophthalmologist grading. And this is the correlation between the matrix and sensitivity. Specificity analysis by excluding images in each patient deemed to be of insufficient quality by the AI algorithm, but deemed gradable by the ophthalmologist. The high sensitivity for referable diabetic retinopathy using this system is also observed by the AIOC AI. An image was captured by the same camera with acceptable levels of specificity. And an offline AI algorithm does automatic grading of the retinal images, providing the results immediately and does not require an internet access. Reports can be made readily available to patients even in the remotest locations, and only those detected with RDR, the referable one, would then be referred to an ophthalmologist. Offline AI for community referral diabetic retinopathy screening using a smartphone-based fundus imaging system, and according to me, you can create job opportunities for a non-skilled worker to become a semi-skilled worker. And general practitioners, primary care physicians, and other caregivers can easily diagnose referable diabetic retinopathy using this simple and affordable innovation. The potential to make a huge impact both on the disease social and economic dimensions. And advanced image processing capabilities allow clinicians to work even with low resolution fundus images and relatively lower cost than the manual methods. And accuracy of about 90% according to the initial pilots, which improves as additional data sets are gathered. And there is a disadvantage, and a negative AI-based finding may give the patient, which already Dr. Rajalakshmi pointed, a false sense of security. And we did a community diabetic retinopathy screening, hope to come in the Guinness record. We screened about 649 diabetic patients using fundus on phone. 53 were diagnosed to have diabetic retinopathy. And WHO believes that 80% of all visual impairment caused by DR can be cured with regular screening and early detection. And I think prevention is better than cure, you know. And this is a slogan which I am propagating as a AOS president. Are you a diabetic or hypertensive? And I think we'll make some stickers and probably put in every clinic or in public places. Do you know you may go blind? And probably have a website which will give details for more than this. Thanks to this, we are celebrating 200 glorious years of modern ophthalmology. And I thank Rajiv and Kim for giving me the opportunity to be a part of the DR screening program in India. And even though I'm the president, but I think we need people to work. And I want to quote Dr. Abdul Kalam, anyone who converts a challenge into an opportunity through innovation creates wealth. He or she indeed is a leader. And I want to question all of you, are you one? The reason is, I think I need everybody to screen the 73 million diabetics in India. Thank you.
Any questions?
Are you continuing the screening and using AI in the slums or whatever?
That's what we are using in the we have got an agreement with the Mumbai Municipal Corporation. So they have 55 centers. So where we are doing this. In the slum, we are not started still. As a project, we made a IRB approval for this, and we are doing that. We are continuing doing that. But I think we have the MOE for 3 years. 147? I agree, but how many years we have? 3 years for at 147 days. So at present, the municipal corporation is giving a place where a particular center has diabetic patient coming on a day for collecting their medicine. So now the medical officers have been put on a rule that these people have to check their retina. So we have a continuity also. So if a patient is normal, they'll come every 6 months, or at least every 6 months we'll check the retina. And then if we are diabetic, then accordingly referral center. And we are insisting that we screen, diagnose, and treat also. And if they insist on free, I think no questions asked. We are offered free treatment in this particular thing. But otherwise, in the slums, whoever can afford, we are charging some 30 rupees for consulting. And how much for laser? 900. That is very few. I think 95% are free, which is not sustainable. We have to learn from Arvind. Yes?
You mentioned FDA guidelines have 85% sensitivity, 82.5% specificity. As an ophthalmologist, what is the number that will give you a sense of confidence and comfort that you can start trusting the
Maybe Rajiv and more experience on this.
WHO has given some guidelines for screening. Any test, if you want to use it for screening, the sensitivity and specificity should be more than 80%. That any test, it may be a test for a lab test for some disease or for retinopathy, it is the fundus photograph or AI algorithm. As a screening, not for diagnosis.
Thank you, Kim, and thank you, Rajiv, being a part, and thanks for including me. Thank you.
You are a chairperson, sir.
I know, but I'll take your, I'll apologize, and I have to go and get ready for the general body.
I know.
So thank you very much for.
Your programs.
No, I know. I agree. It's our program.
Yeah.
So I'm happy that all so many of you are here, because the reason is we need every ophthalmologist, every general practitioner, and that's what Dr. Kim is trying to drive in all the meetings he goes, and he's addressing that. Diabetologists, physicians are to be educated. I really don't know, it's like, according to me, at least in Bombay, I feel it's like hitting against a rock, because Dr. Rajalakshmi is working in a diabetes center. She is actually in a luxurious position. And we have kept a diabetologist in our eye hospital, but still the patients don't go. So I don't know, there's some mismatch. And I think best will be, which I did in '88, when I went from Chennai to Mumbai, at that time Madras to Bombay. I decided and I educated the public, if you have any distortion in vision, please come to a retina specialist. And before undergoing cataract, you get a retina check. So at that time they didn't know what is retina. So I am glad I did that. Same thing I'm going to do through the AOS now. I'm happy that we have signed, AOS has signed a MOU with the International Advertising Agency, and AOS and Allergan has got collected money, and we are making a 27 lakh worth movie for a public initiative where no individual name is there. It will be a AOS Allergan initiative, and I am glad I got the news. Deepika Padukone and Andrea Agassi is going to release on 22nd. The reason is, every public, if they know, I think they will come to you. And that's my dream. If every patient goes to a free clinic or a charitable clinic or a paying, if 73 million gets checked, I think I'll be the most happy. I've given myself a deadline 5 years, and that's how the committee is made 5 years. And I hope by the time at the end of 5 years, we may screen 100 million, and I need all the time support from Kim and Rajiv. Thank you. Thank you so much. And
thank you. I would now request Dr. Surbhi Gupta. Surbhi had received her Master of Technology degree in Computer Science from International Institute of Information Technology, Hyderabad in 2017, with a specialization in data science. She has joined Microsoft in June 2017 as a software engineer. She's working on medical imaging and predictive APIs for AI network for healthcare, using cognitive APIs, machine learning, deep learning, image processing, cloud infrastructure, and IoT edge technologies in the team. Dr. Surbhi.
Hello everyone, I'm Surbhi Gupta from Microsoft, and I'm here to present Microsoft AI Network for Healthcare. So let's begin with the key issue because of which we started this project. So as we all know, quality care is uneven around the world. So when we talk about high income countries versus low income countries, or maybe in the same country when we talk about different cities, the care is different, which is mainly due to availability of skilled technicians, clinicians, standardization, as well as limited resources at the point of care. So we thought how AI can help bridging this gap. So AI can help by early screening, by collecting large amount of data from world-class hospitals, building AI models, and provide early screening and prevention. It can provide a standardization wherein every time and everywhere you call the model, it will give the same output. And also by deploying intelligent resources at the point of care where there are limited resources and limited connectivity. So this is the AI network for healthcare, where we have intelligent cloud and intelligent edge. We have data collaboratives, which are world-class health providers and institutes. We collect data from them, we get expertise, and in the end, they also validate our models. Using the data, we apply AI on different diseases. So currently, we are in ophthalmology, cardiology, and pathology. We have models for all these fields, and we also have things on the cloud as well as on the edge, so that models can work on offline mode where there is no internet connectivity. And with the help of government and hospitals, we provide last mile care. So these are our health collaboratives. On top right, you can see there are some awards which our team has won. And I'll talk about the active deployments. We are also working with a number of institutes, and Shankara Nitral is also one. And active deployments, we have refractive error API with LV Prasad. Our device partner, Forus Healthcare, we have our models integrated with them. Then Bascom Palmer also for eye care. With Apollo, we are in cardiology. So we have created an API for Indian population, which can predict what are the chances that a person can get heart attack in next 7 years. And we have collected a number of health check parameters of the person and some past 7 to 10 years of data for this. And with SRL diagnostic, we are in pathology and mainly we are receiving cancer images. So let's look at a short video of our project.
What if we lived in a world where every medical practitioner around the globe could tap into the learnings and experiences of their peers and seniors? A world where healthcare workers from various socio-economic backgrounds can enhance predictions and treatments to patients using data captured over large. What if we lived in a world where every medical practitioner around the globe could tap into the learnings and experiences of their peers and seniors? A world where healthcare workers from various socio-economic backgrounds can enhance predictions and treatments to patients using data captured over large, high-quality and diverse settings. Presenting Microsoft AI Network for Healthcare, a vision to democratize AI to enable clinical efficiencies and provide better healthcare by bringing together world-class healthcare organizations that collaborate and share anonymized data, medical knowledge, and clinical validation. The network automates this knowledge using Microsoft's artificial intelligence and enables healthcare organizations and governments to apply insights at the last mile care via Azure cloud-based APIs.
So we'll talk about one API and understand the end-to-end workflow. So we have Retinal Imaging API. We all know the prevalence of diabetes and diabetic retinopathy diseases in the world and how dangerous they are. So we have 422 million people with diabetes, and this number is estimated to go up to 592 million people by 2035. In diabetic retinopathy, we have 93 million people. So as we all discussed, early detection is the key to solve the problem. Now with mass screening programs, what are the current challenges? So there are particular 3 types of challenges. One is the image quality. So when you go to a rural area, conduct a mass screening programs, and when you come back, you see that half of the images which are taken is not of good quality, and you cannot give any diagnosis on that. The other is of untrained professionals. And one is expertise at the point of care. So there are places where there are limited resources and no internet connectivity. So we basically solved these 3 problems with the help of, by 2 ways. One is we created APIs. So as soon as you take the image, it will tell what is the image quality, if it is acceptable or the image should be retaken. Then if the image quality is good, then we talk about the DR. And also for the expertise at point of care, we have IoT Edge, where we have deployed these models to work in offline mode. So where there is no internet connectivity, it will also give the prediction. And whenever you come back to the cloud, you can upload your all information and images. So these are our image quality and DR detection APIs. First, as soon as you take the image, it will tell whether it's a relevant fundus image or not. Because sometimes they also take the outer eye image or some random images. When it passes that check, then it tells whether it has spotlight, which is hiding the DR features, if the image is blur, if it is sharp, if it has lens artifacts like we discussed, dust particles or the flash. When it passes all the quality checks, then we pass it to our DR detection API. We also detect whether the optic disc is clearly visible, macula is visible, and blood vessel ratio in the image, if the optic disc is cut or faded. When we pass this check, then we detect exudates, hemorrhages, neovascularization, and then give the consolidated report. And also for the last mile care, as I mentioned, we have these models working in offline mode as well, and we have tried this pilot version with 4S devices. So like Microsoft and our data collaboration is equal to impact. Thank you.
Thank you. Any questions?
Subhi, thank you for the nice talk. So is this available as an algorithm at this point for diabetic retinopathy?
Yes. And there are various pilot versions also going on. So in Andhra Pradesh, we have APPSC, which is Andhra Pradesh Government plus Apollo Hospitals, and they are doing live screening every day. And I think there are some 1,000 calls in a day on these APIs.
So that's across all the patients, not just diabetic patients, right?
That is across all the patients and I think they are adding centers. So right now they have some 40 centers and every week they have planned to add more.
But those images are seen by a ophthalmologist, if that's correct.
First is mass screening program.
Yeah.
Then there we use image quality thing, and then after that it is seen by ophthalmologist.
Thank you.
Yeah, please.
Yeah.
So for the microhemorrhages and the whispers, these are like a two-stage model or it's more like a separate model?
I'm not able to hear you.
Can you use the mic?
Yeah.
For the hemorrhages or the aneurysm of the blood vessels, are they separate model or is it more like a two-stage model actually used? The final diagnosis or screening result
No.
actually uses the information from
Okay.
those.
We have one deep learning model which tells DR or no DR, but we have few image processing techniques also in place, and we are not right now reporting exudates and hemorrhages outside, but we have everything working. Whenever our management decide, we'll report this outside, but there is only one deep learning model. Yeah. Yes. 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 So image quality we report in like 4 categories. One is excellent quality, where you have optic disc, macula, blood vessel clearly visible, everything is perfect. Then we report a moderate quality image, where we have little bit problem with blur and sharpness, but still if so we have a parameter in API. If you mention that you need optic disc and macula in a proper position, then that is mandatory. If you mention okay, that's okay, I am okay with the blood vessel and these things, there is a knob to fix that. So there is moderate quality, then we have bad quality, and then there is discard. So images which are non-fundus or which is completely spotlighted, we discard that. But the things are in operator's hand. They can tune. Okay. Yeah. Yeah, we have knob in API parameters, and also the accuracy we report in such a way that for excellent quality images we have this accuracy, but you accept moderate and good quality images, that is the accuracy. Yeah.
One question, I mean, both to Google and Microsoft. Do you have like any image enhancing kind of software? Because we can't expect definitely like what we do in real time versus what happens in a clinic setting. Real time when we take it in telemedicine, etc. We can't expect really crystal clear images, frankly speaking, because it will be done under dire settings. So can image enhancing softwares which are either by Google or AI help to overcome this problem? Because if we are going to have too many ungradable images, then it's not going to help the ophthalmologist. Then we'll have more number of patients, in fact, to see.
Okay. So by image enhancing, you need a software wherein you can adjust contrast and as well as this contrast and something.
So that it doesn't say it's ungradable, because when we're going to have ungradable images, then automatically it becomes referable to the ophthalmologist.
See, limited things we have, but obviously if blood vessels are not captured properly, or if the image has lot of dust particles and so on, then we leave up to the, we say that the image is of moderate quality with this things visible and this things not visible. Now it's up to the, experts if they still want to go ahead with the image or they want to discard it.
AI wouldn't give a diagnosis.
It will give a diagnosis, but again the thing is, with good quality images we are more sure, with moderate also we are there, but for bad quality images we are not sure about our accuracy.
You give a confidence interval of your diagnosis.
We mention the quality of image, moderate and good, and then we grade DR and no DR.
So the deep learning model itself has a function of like image processing itself. So one of the strategy we can do is include those bad quality images in the training dataset. And if the information is still there, the deep learning model can potentially learn to enhance the signal from there and make the diagnosis from those previously ungradable images.
Thank you.
Thank you. So really it was a great session, and I'm sure one thing which I felt is that this is one of the first AIOS where AI session is there, I'm sure 1 year is a long time. Next AIOS, definitely I'm sure there'll be multiple sessions because it is coming, it's there, it is not the research now. And not only diabetic retinopathy, glaucoma, AMD, refractive errors, and LASIK. I think another work which has been happening with Microsoft is LASIK. There are a lot of other things which are coming way. So I think we'll see soon the applications of AI more into our clinical practice. Thank you.